Hi, hello, hello, hi. It's Friday for me. It can be any day you want it to be. Is it your birthday? Somebody's birthday today. It's Darren's birthday today. Oh, I should do a birthday video for being 31, which is a prime number. But whatever. Okay, lesson 11, please. Thank you. Have your notebook handy so you can write down these properties. You're going to want to refer to them as you do the next sets of lessons and getting ready for the next test in 5 lessons. So today it's multiplying and dividing real numbers. We've done adding and subtracting, and now multiplying and dividing real numbers. We're just going to knock those all out at the same time because multiplication and division are cousins. They are very close relatives, and the rules for them are very similar, especially with real numbers. Remember, real numbers, we're talking about the number line, and any number that can fit on there between whole numbers counts as well. Decimals, fractions, positives, negatives, you got it. It's a real number. So let's start with kind of the basic things that you already know, and let's just give them a name. Okay? So the first one up today is the multiplication property for negative 1. For negative 1. Basically, this is the sign change rule. Okay? That if you've got any number, and we're going to call it A, and you're going to multiply it. I'm just going to use a dot rather than a X because that'll get confusing when we start using other things. And we'll throw in here times a negative 1. Okay, and put in parentheses so it's not subtract 1, it's negative 1. That equals negative 1a, or negative 1 times a, which just equals negative a. So if you multiply something by negative 1, you can just get the negative version of that number, whatever that number is. But I want you to think about this thing backwards too. That if something is written as negative a, you could also write it as negative 1a. That might come in handy as you're trying to combine terms and whatnot, and you just have an a and another a and another a. Each of those is a 1a, whether a positive or a negative 1a. You can always write that understood 1 in the front, okay? Or that negative a is always a times negative 1 if you want to separate that negative 1 out away from the a. So there it is. It's going to change the sign. Anytime you multiply a number by a negative, it's going to change its sign. That's basically that rule. Second rule is if you multiply something by 0. Okay, we have to keep track of all these things. Remember we talked about closure, and in math we'll talk about sets and rings and these number theory types of things, set theory types of things. We need to know what happens when 0 comes into play. With addition, it was a plus 0 equals a. It doesn't do anything. It's the do nothing operation. But with multiplication, a times 0 equals 0. 0 turns everything into 0 with multiplication. Divide by 0, can't do it. But multiply by 0, it turns any number into 0. That's a useful thing to have just in your back pocket. It's called the multiplication property of 0. Pretty straightforward, right? That makes sense. You already know everything divided by 0. Anything divided by 0 is 0. Even 0 divided by times 0 is 0. Multiplication, not division. Stop talking about multiplying, Spence. Except now we got inverse properties of multiplication. So this one is if you take a number and you multiply it by its inverse, or sometimes we'll talk about its reciprocal. A could be written as a over 1 because it's a rational number. And then if we flip that around and multiply straight across, a times 1 is a, and 1 times a is a. This turns into a over a, which equals 1. So if you want to undo multiplication, you can multiply by something's inverse. Yeah, that's going to be very handy as we solve equations. If you want to undo multiplication, you can multiply by an inverse. Okay, so a times it's 1 over a equals 1. I put that extra bit in there just to kind of show you how that jives algebraically or even arithmetically. But there you go. That's really all that property is. So let's take the number 12. To get to 1, we've got to have to either divide by 12 or its equivalent multiplied by 1/12. Okay? That is kind of the next thing there, that if you've got divided by a number, you can multiply by its inverse, and that's equivalent. That's the exact same thing. Let me say that again. If you've got, and I think I've shown this before, let's say that we've got 12 divided by 4. That's the same thing as 12 divided by 4, which is the same thing as 12 times 1/4. That's awfully handy when we need to pull things apart, especially when we start throwing more letters in there. And so there we go. 12 times 1/4 is 3. You can even try that on your calculator. Type it in that way. 12 times, get a fraction by going alpha x, and then plug in 1/4. You'll hit enter. You'll get 3. We already know that's true, okay? But this just is another tool for us to rewrite a problem so that it makes more sense, or that we can see how this thing gets put together. So we kind of know the nuts and bolts. We know what's going on under the hood. We're not just driving the car, but we know what's going on underneath the hood. What happens when we push the gas pedal? That kind of idea. This is what goes on behind the scenes. This is the math that we don't see. That's the inverse property of multiplication. A number times its inverse equals 1. That's important. You got to know how to get to 1. This is called unity. We want that oftentimes in a problem. So we got to have that property in our pocket as well. Next is the multiplication of signs. That is, if we take a negative times a negative, we take a positive times a positive. And I'm just going to write these rules as pluses and minuses. All these will be multiplication of things. Okay, take a positive number, and use parentheses to mean multiplication. Positive times a positive is a positive. A positive times a negative. Oops, that's sloppy. Times a negative. Don't put is a negative. A negative times a positive is a negative. And then the other one up here, negative times negative equals positive. And the way I just look at it is like, those are just sticks, okay? And so if I've got 2 sticks, I've got a plus sign. If I got 4 sticks, I got a plus sign. If I've got 3 sticks, that's a plus sign and a minus sign, okay? So 2 sticks, it's like I can take this little piece and turn it this way and plop it right on top of there, and I've got a plus sign. So negative 2 times 4 is going to be a negative number. And a negative 2 times a negative 4 is going to be a positive number. Those rules you've known hopefully since about 5th or 6th grade. And the problem works the same with division. Okay, we put division right here. Can we see that? Yeah. If we take a negative divided by a negative, that equals a positive. If we take a negative divided by a positive, that equals a negative. Take a positive divided by a negative, that equals a negative. And if we take a positive divided by a positive, we get a positive. Again, same signs, you get a positive. One of each, you get a negative. Okay? That's how we can combine those ideas. The last thing is something I already talked about, but they're just going to throw in fractions, like regular fractions, like 2/3 and 3/4 and whatnot. You get that down? If you haven't, hit pause and do that. Talk about this last thing. Just see, we're doing this with fractions because the category was real numbers, and fractions, irrational numbers, are real numbers. That if we've got something like, they write a problem, 2/3 divided by 3/4, we're going to stop writing stuff like this, especially like division, sideways. I mean, what does this mean? This really means 2/3 divided by 3/4. And that's a little bit, that's hard to picture in your head. How do I take something that's 2/3 of something and break it up into pieces that are 3/4 big of the whole? Like, what is that? You know? Give me something that's 2/3 of something that's divided into 3/4 parts. I mean, we could do that. We could draw a picture, but it's kind of Singapore math, and I don't know how much of that you've seen before. So let's do what I talked about already, and that's say that dividing by something is the same thing as multiplying by its inverse or reciprocal. Okay? Instead of writing it with a fraction bar, let me write it like this: 2/3, and then we're going to multiply, and then we're going to flip this thing upside down. So that's the same thing. It's the same thing. And now we follow the rules for multiplying fractions, and we just multiply straight across. That's the same thing as 2 times 4 on the top and 3 times 3 on the bottom. 2/3 divided into 3/4 parts gives us 8/9. Now, if we throw in some signs into that, it's the same thing. We'll just keep track of pluses and minuses. For instance, let's turn this into, leave that divided by, but let's do this like 2/5 and 1/4. But this one's negative and that one's positive. Let's just follow the rule. Let's keep that negative out there, and then let's make it multiplication by its inverse. Now, this is a positive and this is a negative, so my answer has to be negative. And I really I think it's a good idea to start writing down your answer as soon as you know something about the problem. You don't have to wait to the end to hold on to that negative and then write the whole thing down. You can write the negative down right away. You know it's going to be negative because you got a positive and a negative in there, and that makes a negative. So this is why the rule works for both multiplication and division the same way, because division can be written as a multiplication problem. Negative 2 times 4 is negative 8. Oh, I already wrote the negative. Let's just put the 8 there, and then the 5 times 1. So negative 8/5, which I prefer to write the answer that way rather than negative 1 and 3/5. This is better. It's cleaner. It has just one numerator, one denominator, no mixed fractions, please. The book, I don't know what the book will do, but for me, this is preferable. Okay, keep track of your signs. Use these basic properties. Probably the one you want to remember the most, or that would be the hardest to remember, is how to do the dividing by another fraction. So remember, just change that to multiplication and use its inverse or its reciprocal, and then carry on, and you should do fine. Yes, you should.